Okay, today we are actually going to go through the scientific notation part of your notes. Now, this is the last set of notes that we're going to take in this first unit. Again, I know your note packet is a little messed up, but we will fix that later on. But the scientific notation is the last ones that you are going to need before we finish this out and move on. So we've already gone through all the dimensional analysis. I'm going to slide through all of that real fast. Okay, scientific notation. So the whole point of scientific notation is that it's how we're rewriting really large or really small numbers into something that is just easier to use. It's a lot friendlier. It's much more nice to look at than these massive numbers we might be dealing with. So the whole format of it is that we're using just the digits with a decimal point after the first one, followed by a times 10 to something power. So if we look right here, if we have 50,500, wow, that's really fun to say, we can put a decimal point after the farthest left number. And then after that second 5, we can cut off the other zeros and we count over how many decimal points we shifted it. So 1, 2, 3, 4 to get 10 to the 4th. So you're going to have one number, point, whatever other important numbers you have, times 10 to whatever number you move the decimals over. So here are all of your steps. We are going to have a number and move the decimal so there's only one number in front of the decimal. Then we rewrite it as that number, point, whatever we need to, with a times 10 after it. We put an exponent after the 10, which is going to be that little number up top, to tell us how many places we move the decimal. And when we start with a big number like 50,500, then our exponent is going to be bigger than 1, meaning that it's not negative. But if we start with a small number, meaning that maybe it's 0.0000759, so if there's nothing already in front of the decimal point, then our exponent is going to be a negative number. So we're going to go through a couple practices. So we're going to convert 101,000 into scientific notation. So I have my decimal there at the end, and I need to move it so there's only one number in front of it for scientific notation. So that's 1, 2, 3, 4, 5 places. And I would get that 1.01 times 10, because that's what we always have to put, and then an exponent of 5. So times 10 to the 5th power, because I moved that decimal 5 spots over to get it where it is now. And because I am working with a big number that I made smaller, my exponent is positive. Now if we're going to take 0.0098 and put it in scientific notation, start with my decimal, and I need it to go after that 9 so that the 9 is the one number in front of my decimal point. So that moves it 1, 2, 3 places. So I put 9.8 with my new decimal spot times 10, and I'm going to have a 3 because that's how many spots I moved my decimal. But I moved them to make a small number bigger. So I started out smaller and I went bigger. I'm going to put a negative sign. And what this negative sign essentially means is that 9.8 will get smaller when I rewrite it out because I'll move my decimal over this direction. So we're going to convert 2.057 times 10 to the 2nd power into standard notation. So that just means that we're taking it out of scientific notation. We're getting rid of this back part right here, the times 10 to the second power, which means we have to shift our decimal over. We're going to move the decimal 2 times because that's what that 2 stands for. And because it's positive, we're going to make this a bigger number, meaning that our decimal is going to move this direction. I'm going to get 205.7 as the original number I'd start out with before I turned it into scientific notation. So standard notation is just my original number without all the fanciness at the end. So convert 3.1 times 10 to the negative fourth into standard notation. So taking it out of scientific notation, making it just a number. So I have a negative 4, meaning I'm going to move the decimal 4 times. But the negative means that I'm going to make this a smaller number because negatives are smaller than positives. So I'm going to end up moving my decimal point over to the left. And when I do that, I have to make sure I add in all my zeros, and my decimal is going to be all the way over here. So to get rid of my scientific notation, I end up with 0.00031. So here are some practice times that I want you to go through in your notes, and we will talk about these in class. I will give you the answers, but please let me know if you get stuck on them at all. So 354 million in scientific notation. So my decimal is over here at the end. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to leave just a 3.54. And then I want you to finish writing that in scientific notation. For number 2, I'm going to have to make this small number bigger. So I'm going to be going 1, 2, 3, 4, 5 places and start with 9.6 at the front of my scientific notation. So I want you to go ahead and work those out. And then I want you to finish the practice page that are in your notes after your dimensional analysis practice and bring that completed to class so that we can check it off and make sure we know what we're doing.